Hello and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of area and volume. Specifically, we are looking at a trapezoid, how to find its area. And this is standard 6.8D in the great state of Texas, and we are using item number 7 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So, theoretically, this is a playground, but it doesn't really matter because we just need to find the area of a trapezoid. Now, if you look on your STAAR reference chart, this is what you're going to find for the area of a trapezoid. A equals 1/2, and then it's going to have parentheses and a little b sub 1 plus b sub 2 times height. There's actually a few different ways we can write this. Sometimes you'll see it like this: b sub 1 plus b sub 2 divided by 2 multiplied by height. This is an important fact to understand. Multiplying by 2, or multiplying by 1/2 and dividing by 2 are the exact same thing. You can actually distribute this out. You can say b sub 1 divided by 2, or multiplied by half, plus b sub 2 multiplied by 2, and then all of that, once you divide that by 2, many different ways to find it. But here's what we're looking at. Your basic rectangle, quadrilateral, it's got a base times height. That's how you find your area. Well, the problem with this is a quadrilateral, this is a four-sided shape, but you've got these lines right here that are diagonal. So what we need to do is we need to find the average of the two bases, because we've got a short base, 36, we've got a long base, 68. And so what we do is we find the average. What's the middle point between 68 and 36? That's what adding both of them and dividing by 2 does right here. Now, so B1 and B2, it doesn't matter which one you label as which, because you're just going to end up adding them together. But those are your two parallel lines. There's only one set of parallel lines in a trapezoid. It's the two bases. So we're going to take both of those. So let's see, 1/2. And we're going to take 68 feet, add that to 36 feet, multiply that by the height. We'll just take this top equation here. So let's see, 68 and 36, that's going to be 14,104. All right, so 104 divided by 2, or 104 multiplied by 1/2. Either way, you're going to get 52. That's the average of 68 and 36. That's the midpoint right there. And then we need to still multiply this by height, and this is the only real trick in this particular problem, is you've got two numbers you could possibly use. You could use a 34, and you could use a 30. Now, the height is actually, unless it's a right angle trapezoid like this, but it's typically not going to be included as one of the sides. So if you're looking at this type of trapezoid, then your height is right here. Most trapezoids, you are going to see this dotted line right here, and they have to provide you with a height because your two other sides are slanted, and height has to be perpendicular. You see this right angle right here, perpendicular to the bases. So our height is 30, and so that's our trick. We don't need this 34. We would need it if we wanted to find perimeter, but we're not looking for perimeter. So we're just going to do 52 times 30. And if you remember your multiples of 10, we can just do 52 times 3 if you want, and then add a 0 to the end. So 2 times 3 is 6, 3 times 5 is 15. And then since we multiplied by 3 and it's really 30, we're going to add an extra 0. And there we go. Our answer is going to be 1,560 feet squared. It is feet squared because we're dealing with area. So we need to put feet squared right there. And if we were to multiply by 34, you'd get that 1768. And the other two are wrong as well.